Okay, let's look at this question here. It says, which score indicates highest relative division? Well, without saying z-score, I bet a lot of you are going, what? What does it mean? Well, what we need to know is we need to know our z-score formula, okay? Which is z equals x minus x bar all over x. So let's talk about what this means. X is the value, okay? X bar is the mean. And that little s is my standard deviation. I'm going to write it as d, okay? Now, I just need to plug this in. And when it says highest relative division, it means the biggest one, okay? Pretty simple now that we've broken it down and figure out what this question is asking. I'm not going to show you anything. Plugging these along, go ahead and I'll do it. So, for the first one, I need to do all these to figure out which one has the highest. So for A, okay, it's 3.2 minus 4.6 all over 1.5. I plug that in and I end up with negative 0.93. Now the next one, I use 630, that's my x, and 600, all over 200, and I end up with negative 0.85. So now these, I do 43 minus 50, all over 5, and I end up with negative 1.4. Now, looking at these numbers, if you remember, they're all negative. Okay? So which one's the biggest? Well, the negative numbers, the smaller the number, like the smaller the number actually is, like 1 and 2, the bigger it is, if it's negative. Okay? If it's like negative 1 is bigger than negative 5. So in this case, negative 0.85b, that's the winner, that's the one, okay? Now, so this is a problem. Alright, the problem's still me to construct a box plot. We'll get it and just start off, get my stuff in order. So let's do that. So I put this in order, and there's not many numbers, so that's really nice. Okay. I also need to do the 5-number summary and find my inner quartile range. Let's do it. Okay. I notice here that I have 7 values, so right away I got my median or my Q2. So let's do that. So I got Q2 slash median, which is 19. So off of Q2, I need to find Q1 and Q3. Well, if you remember, once you find your median, it's kind of isolated. And so then now my Q1 and my Q3 is based on those 3 numbers on each side. So I pick the one in the middle. Well, in the first one, the 8's in the middle, so that's Q1. The second one, 32's in the middle, and so that's Q3. I need to also say what's my lowest and highest value, which I see here. Lowest is 6, highest is 54, okay? And now to do my inner quartile range, I just subtract, I'm going to write it right over here. I just subtract Q3 minus Q1, or 32 minus 8 to get 24. So now I've done the 5-number summary, I've done all this work, and then I can use all this while to do my box plot as well. I have to if you want to do one. So I'm going to use all this to construct my box plot. See, it's not that bad. Now, let's say for instance, I don't have an odd number of numbers up there, okay? And I have to figure out what my median is. That's when you take the average of the 2 numbers. So like, you know, I would have to take, let's just say hypothetically, 19 plus 27 and divide by 2. That would tell me my median or my Q2, okay? So just know that you have to do that in those cases. Now, let's go down to our box plot. So I'm not the best drawing. Just put that out there right from the get-go, okay? So you want to have this. I'm going to do 0 to 60. Nothing fancy about that, okay? If you don't start at the top, my data started at 6 and ended at 54, so I'm trying to get as close as possible to those numbers, okay? Making sense. So I start out at 6, well, it's out there, and you can't start at it. South's about 54, so, you know, maybe about there. So this is 54, okay? Oh, it's going to be a crooked line, but it will. So, I'll fix this. Okay, that's pretty good. So about like that. Alright. Now, that's that part. Now, from here, I need to do my quartiles from the box. So, really close to 6. And I'm going to go to 32, so I mean, I'm not the best at these, like I said, that one there. And so this is 8, and this is 32, okay? And my median 19, alright, is a little closer to the 8, so just a little off to the side like that, okay? Now, in this case, if they ask, this would be positively skewed. If you notice, part of the reason, you know, a lot of space over here, and I mean, just a little to the left here, so if they ask me something like that, this is an example of positively skewed because I have all that open space to the right. I have this box up here, and so my median is a little closer to the 8 than the 32, so I just want to let you know that if they ask questions like that on the test, but this is exactly what my box plot would look like. So it's not hard to do. Alright, let's go on to the very last problem here, then we're done. Chevy here. Some people are saying, when do I know when I use it? Well, normally the teacher will say you use it, please. But if not, notice it says they give you a mean, they use standard deviation, they want to know what percentage of the values will fall between. Chebyshev's theorem also uses stuff like what values would be, or would be the range of like 75% of the distribution, or 88.89. So you see those kind of numbers, you know they're talking about Chebyshev. Make sure you know how to do this, okay? So in this case, it's actually really easy. The first thing I want to do is I have my mean, alright, this one. Use next bar, okay, standard deviation is 2. And I need to know, you know, percent between 10 and 30. So to figure this out, the first thing I do is I take my highest number, my high hard range, 30, and I subtract the mean from it, okay? I do this, and I end up with 10. Now I take this 10, and this is what I need to do to find the K for Chebyshev. I take the 10, I divide by 2. Hey, guess what? It's 2. Alright, it's not, that 2 is not, this is what I, you know, I well, you know, okay. Let's do it in this case. Let's do it in standard deviation. Alright. Now, from here, this ends up being 5, okay? So, I take this number, and my formula is 1 minus 1 over, you know, k squared. And so I have 1 minus 1 over 5 squared, which is 1 minus 1 over 25. Now, let me move this out of the way, okay? This ends up being, when I punch this into a calculator, 0.96, or 96%. And if I see here, it's an option. So this is how you would use the Chebyshev formula. It's a very, very easy formula. A lot of people get confused, they don't like it. But it's not that bad. I know some teachers might, you know, they might rush over in class. It's not going to be the problem very quickly. But this is one use of the theorem, and the other one is if they're asking you for, you know, what would be between 2 standard deviations and 3 standard deviations, using a percent of like 75 and 88.89%. Alright, so hopefully you know how to graph and calculate, you know how to use it to help you out on this test. If not, you can always come to admin support in the lower level of the library and me, Jennifer Winkleman, and one of our tutors will be happy to show you how to use the calculators, the graphing calculator, to help you on this test and in the class so that you can do your best. Well, if you do on the test, remember it's multiple choice. Try to do the ones that you know the best first, and then go back, make a little note next to the ones that are too hard, so I don't have to waste 20 minutes in the wrong formula, the wrong problem, and later on you realize it. Okay? So, hope this helps. Study, and good luck. Bye-bye.